Do I need to turn this on? You're good. Okay, I think we are ready to start. Thank you all for joining our very first Alchemy demo day. We have a clearly a live audience here. We're also streaming this on our YouTube channel through the department. So, you're being recorded, you're being live streamed, just FYI. What I'd like to do today is give our teams, we have two teams here that are going through the Alchemy process for the very first time. And I really want to make sure there's adequate time for them to come up and tell you what they're doing and demo what they've built to date. But many of you here might not know much about Alchemy. So what I'd like to do is actually start off the demo day with about a 10 or 15 minute overview of Alchemy to perhaps entice you to check if this fits what you want to do here at Illinois. And then we'll just move on to the demos and we'll wrap it up with a few concluding remarks. You should know that Alchemy is a big experiment. It's something that we started with support from the department and ultimately support from IBM late last year. We recruited some students who started through the pipeline that I'll describe to you in a moment, essentially in January. So what you're going to see today is really kind of the first sampling of that experiment that we're calling Alchemy. But I'd like to start off by kind of motivating Alchemy and telling you about why it's such an important concept that's now part of this department. And it really starts with taking a look at the startup journey. While I want to stress this to you, Alchemy is not about entrepreneurship specifically. It's kind of rooted in the whole idea that what we do and here within ECE and CS in the College of Engineering is create technologies that are potentially commercializable. So if you take a look at that journey that some of you might be on or may choose to go on, it really looks like this. A team is formed, the team makes a technology. The technology is part of a product, and you put together a plan to build that product, to get the users, to grow the company, and to get the revenue. And you put that plan together, you raise money, and the expectation is that all of this will grow and the revenue will come and everybody will be happy. Investors, you, and what other partners you have. But the reality of it is, oftentimes, in fact, more often than not, you make it part way. You don't quite hit the revenue that you want or get the users you want or quite build the product that has the right fit with the market. But it's not to say that everything you've done is wasted, because what you've done is you've assembled a team, and the team has built some pretty novel technology, hopefully. And that in itself is of value. So if you take a look at all the M&A that happens, the mergers and acquisitions of tech companies out there, the vast majority of them, over 90% of them, are primarily about the tech and the team. So the product, the users, the revenue, you didn't quite get there. And that's just the reality, because the market is hard, and the timing could be off. The product might not fit. The users might be too expensive to acquire, whatever it is, but you have something of value. So most of the tech M&A, the mergers and acquisitions that happen out there are for you, your team, because you've distinguished yourself in building that core technology. So and that is really what Alchemy is about. It's about helping you and your friends and your other classmates build technology that's of commercial value. I think of Alchemy really as a team building experience, because great teams, as we're seeing by the way companies are valued when they're acquired, it's much more about the team than it is about the individual player. And I know maybe you're not a FC Barcelona fan, or maybe not a Messi fan, but I'll tell you this, I was looking for a good picture of Messi or Ronaldo with a team. And I don't have a favorite, but I'm just saying I saw a lot more with Messi with a team than I did Ronaldo. Whatever that means. I was searching for this image. So alchemy, let's get into some details. Okay. It's about creating a collection of students that work on deep tech problems. And we're going to give you 2 examples of what these tech problems are. So ultimately, you and the cohort that comes in are striving to build that technology to work together and become an expert at X, whatever X is, okay? It's not about, the teams are not about writing papers. It's not a research incubator. It's not about getting users. It's not about marketing. It's not about sales. It's really about building. It's about building a project for a long duration. The whole alchemy pipeline is 18 months, 3 semesters in a summer. So during that 18 months when you're with alchemy, what we're doing is we're building an infrastructure of support, of connections, of advisors that are helping you build that technology as you go through the 18-month pipeline. The end goal of alchemy is to give you, as a student, more options. You could, at the end of alchemy, decide, okay, fine, I'm going to go work for JP Morgan or GM, as I would if I graduated normally. But through alchemy, we're enabling you to get acquired as a team, potentially, with what I showed you previously, because most tech M&As are about that team and that technology that team may be very knowledgeable in. Or you might, at the end of the alchemy process, decide that, wow, what we have is worthy of a startup, and we want to go get the startup funded, and you're already one step further along. And now you can make use of all the other resources on campus around entrepreneurship. So that's really the end goal here, is to give you and your team more options of where you can go with each other, by yourself, with your technology. Now let's dive in a little more. As I said, it's a 3-semester, 1-summer experience where we're trying to integrate the experience right now within the Department of ECE. So as you go through, students come in the first semester through a rigorous selection process. Teams are formed during that first semester. You don't have to come in with a team, but we help you identify and mix with other people in your cohort that you might work well with. We also identify projects in that first semester. And then we build. We try to engage with customers as we go along so that we're not developing in a vacuum, but that we're making sure that what we build has commercial value, because at the end of the day, that's really what it's about. There's a summer internship where you get to stay on campus, continuing to develop the IP that you and your team are working on. So here, it's full-time with, I would say, a modest stipend to help you kind of keep the momentum going on that end. And then in the last semester, we call it the launch semester. The idea here is to help you go to the next phase, whether it's to get funded, to exit, or just to graduate with a richer experience of having gone through the alchemy incubator pipeline. Along the way, the idea here is, depending on the type of student you are, whether you're an undergraduate student, master's student, or an MN student, there's course credit, project credit that you get along the way to kind of give you some legitimate time during the semester to build your alchemy IP. Okay. That's the idea here. What we're also doing to make sure that you're getting the support you need to build the project and to keep it on track and to keep it valuable, we're focusing alchemy in a few important, what we consider to be important areas of growth for ECE and CS capabilities. Things like normal technology. Companies like Google and Amazon, automotive autonomy, because it's a very hot area right now, where talent, like we're generating at Alchemy, is in big demand. Agriculture, as we're seeing digital agriculture come to the forefront right now, and in bio and in health, kind of leveraging the other activity that's happening on campus around the Carle College of Medicine. We couple all that with the work that's happening here at the university, the research that's going on, where faculty can come in and help direct you on projects that are at the research level, but are ready for that big commercial step. And what you get to do is participate in translating that research into something that's a commercial artifact, at least on the initial stages of that. So what we're doing is we're bringing companies in to help create that ecosystem. In fact, our first company is IBM, and they've sponsored the very first Alchemy cohort at large. The teams you're going to see are being funded through collaboration with IBM. I'll tell you a little bit more about that in a moment. But the idea here is that as we get Alchemy spun up from research or from an experiment to something that's a standing idea, there is a broader ecosystem within these areas of companies that are providing input to you, paying attention to you, and potentially acquiring you and your team and your technology. So it's a work in progress, and a lot of these companies aren't there yet, but they're coming. I chose these companies because they've already expressed interest. And soon, we hope the partnerships are all there. So last few things. What I want to do is help you understand if you're right for Alchemy. Clearly have to be here for 18 months, and what we're looking for are juniors and seniors. They look ahead, you're able to look ahead and commit to being here for 18 months through the incubator with the right background coursework. So ECE 391 is preferred, CS 225 preferred, again, because a lot of the opportunities we're seeing are within the computing realm. And as well, 400 level project coursework. Ideally, what we're trying to do is layer this onto the MEng program. So if you're thinking about MEng, and this is appealing to you, the timing we've constructed to work out. So as you get admitted into the MEng program in the fall, you can start, if you're accepted, directly within the Alchemy incubator. That's the whole idea. So that's something you'll have to check. Do I have the right background? And am I willing to commit to 18 months on campus to see a full cycle through? But beyond that, really what we're looking for are students that are ready and willing to commit to building something that the world is interested in. Okay. You don't have to be an expert in the topical domain that you decide to go into. In fact, you're going to hear 2 projects where the teams have essentially become conversant in those areas by just learning on their own and talking to faculty that are experts in those areas. Okay. But that's really it. Do you have the right background? Can you commit to 18 months? And do you have the right character for the program? Okay. I'm going to hand it off to our teams here in a moment, but let me just give you a preview. And I said that I would mention IBM because they really kicked off, helped us launch Alchemy this semester. This particular cohort that's started in January, sort of in an off phase. We wanted them to start early, just so we can start understanding the process. So they started in January. And what you're seeing now is the product of their effort of just a few short months, January to May. We launched this in partnership with IBM, the Center for Cognitive Computing Systems Research, which is the IBM funded center here. You can see the teams here. In fact, they're all here, and you'll get to meet them. But as part of our IBM Connection, we have people from IBM that are providing input, as well as tools in the deep learning area that the center has built that help us accelerate in building the technologies that our teams are working on. Okay. Before I hand off, be willing to take a question or two. Yes?
Is there a potential for Alchemy to expand to other areas as well, like in town energy space?
Indeed. Yeah, I think we're looking for opportunities to grow it, certainly within our department. We've got a tremendous backing from Professor Hu is our acting department head at the time. Thanks for coming with me. So yes, if you're in a different area than the ones I suggested, I would encourage you to apply. Yes?
How do you think that, like, with time, this will start to expand, not just like towards like the master's program, but even towards the undergraduate program, trying to get people into it earlier?
I think those are all topics that we're actively discussing within the department. Yeah, because it just feels right that we should offer a project plus team experience throughout our undergraduate curriculum. So last thing I want to say, it's a call to action. We are looking to admit 30 students into the next cohort in the fall. Ideally, you're a junior, senior, MEng master's student. Hoping a lot of MEng students apply because MEng is such a tight fit with the MEng program. If you're interested, speak with Stacy, who's here, who's the MEng coordinator and de facto Alchemy coordinator as it's going. You can submit an application to the website there. And we're going to accept applications for the fall through June 15th. So please drop an application. It's very simple, takes just a minute, and let us know that you're interested. Okay. I would like to now invite the first team to come up, the MIP team. And Edwin, I think you're going to kick us off, right?
Yes.
Okay, let me flip up your slides. Okay. Thanks, Edwin.
Thank you.
Here, let's give you a
Just make sure this is good. Okay, cool. So let's talk about MIP. MIP stands for Millimeter Wave Imaging and Perception. It's one of the Alchemy project teams, starting with the 2019 cohort. These are our team members. My name is Edwin. I'm on the top left. We also have Rehao, who's here. We have Arjun over here. Dash, Charles, and Jingming. Oh, I think that was supposed to happen. So, our mission statement is to develop the main toolbox library for enabling millimeter wave imaging radar solutions. In other words, our mission is to develop the software that will allow a new generation of imaging radar work with existing sensor platforms. To start off, let's have a little bit of background. This is an autonomous vehicle. It is a sensor platform that has the potential to revolutionize the automotive industry. There are 5 key sensors on this sensor platform. We have LiDAR on the top, which provides accurate, high-resolution ranging data. We have cameras, which provide accurate, high-resolution RGB data. GNSS, which provides outdoor geolocation. Radars, providing long-range distancing and object detection. And ultrasonic sensors for close-range detection. Of these sensors, there are 2 important ones for figuring out where MIP stands in this field. Those are LiDAR and radar. So let's dive in to talk a little bit more about those 2 sensors. So LiDAR stands for light detection and ranging. It's a visual-based system, and the way it works is a laser is generated, and the time of flight of the laser pulse is measured to determine the distance to the object. If you look on the animation on the left, there is a mirror that spins around in 360 degrees to give the LiDAR a full view around whatever it is sensing. In the center, there is a video playing for a Velodyne 64-line LiDAR. It's, as you can tell, very high resolution. It's very easy to determine what is around. And while it does have good resolution, there are some problems with this sensor. Two of the most notable ones are the range. Because it is using a laser beam, you cannot shoot a very high-powered laser beam outside at people. That limits the range. And the second thing is, because it's a visual system, you end up having problems with any situation where visual systems fail. So weather, including fog, snow, and less now, but rain as well. Oh, and dark. On the right, that is a picture of a LiDAR data feed in the middle of a snowstorm. As you can tell by comparison, it's very cloudy. Now, about radar. Radar stands for radio detection and ranging, or distancing and ranging. It works similarly to LiDAR in the sense that you are transmitting an EM radio signal and measuring the reflection instead of a laser pulse. The data that you gather is known as an RDC, which is short for radar data cube. The data that comes includes range, speed, azimuth and elevation angle, as well as the reflectivity of the object that it bounces off of. The radar is an interesting technology because it is really old and thus has more of a proven track record. It got its start in the 19th century, where the military used it to track ships out at sea, as well as airplanes. On the right, you'll see a picture of a tower used to defend Britain during World War II from the Nazi Air Force. And on the left, you'll actually see an interesting piece of history about where radar stands with UIUC. That is Memorial Stadium, where there's a crow nest built into the top row. What that was the CSL across the quad. Their job was to research radar, and so they actually did top secret work in that building, measuring traffic on the nearby highway. And work that was done in that building later went on to be incorporated into spy airplanes that they used to look into East Germany, as well as, I think they called it the cornfield system for the US Navy's surveillance program. Sort of poking at the irony of developing a naval surveillance system in the middle of a cornfield. So today, solid-state radar has drastically improved both the size and the cost of these radar sensors. That's a picture of Google Solai's radar sensor next to a quarter for size comparison. As well as the solid-state factor, there are also modern techniques that are improving its performance. For instance, we're using higher frequencies, especially in the automotive range, to improve the range resolution. Additionally, we have multiple input, multiple output arrays that increase the array density, allowing for higher resolution, spatial resolution. Phased arrays allow for digitally steerable transmission beams, and phase-modulated encoding ensures that we have sensor-to-sensor isolation, so you don't blind your friend as you're driving. Now I'm going to pass the, stage to Arjun, who will talk about modern radar performance.
Hi everyone, I'll be speaking about how radar compares to other kinds of sensors. So here on the right we have a visual that compares radars to a visual sensor and a GPS. And so the graph that you see on the right, on the y-axis we have some sort of measurement like speed or angular velocity, and on the x-axis we have time. So the first two graphs at the top show how these three sensors, the visual sensor, the GPS, and the radar, perform under normal, bright conditions. And as you can see, there's a lot of overlap, meaning that the three sensors pretty much record the same information, sort of validating each other's measurements. Going two down, we see how the sensors perform under dark conditions or under poor lighting conditions, and you see these sharp red dips, which indicate failure of the visual sensor. Going two down once again, we see how these sensors perform under poor weather conditions, for example, under rainy conditions. And here, once again, we see these red spikes, which once again indicate failures of the visual sensor. The last two graphs at the bottom show how these sensors perform indoors, and you might notice that we don't have a green line, which elsewhere was used to represent the GPS, and that's because GPS doesn't work indoors. And so the point here is that while visual sensors don't work very well under poor lighting conditions and under poor weather conditions, and while GPS doesn't really work well indoors, radars not only work under all three of these conditions, but work well, making them environmentally agnostic. Here's a quick comparison between LiDAR and radar. Starting with cost, a single LiDAR can cost anywhere between $8,000 to $75,000, while for radars, that range goes from roughly a few $100s to a few $1,000s. And so there's that dramatic difference in cost. Size-wise, on the left here we have 3 LiDARs, and on the right we have a single radar. These images, of course, aren't to scale, but if we were to scale these images, then you'd see that the radar in size compares to the smallest LiDAR on the left. In terms of range, LiDARs typically have a range of about 100 meters, and radars, on the other hand, have a range of about 300 meters. So that's a threefold increase right there. And as I mentioned on the previous slide, LiDARs are environmentally dependent, meaning that they depend on lighting conditions, weather conditions, etc., whereas radars are environmentally agnostic. Here on the right, we have a plot showing cost versus time for both of these sensors, for both radar and LiDAR. As you can see, the cost for both of these sensors has been going down over the years. In specific for LiDAR, the primary reason for this is the introduction of solid-state LiDAR systems, which were a lot smaller than previous LiDAR systems, as well as they didn't really have any moving parts, which was good for the cost. On the left, we have a plot showing how resolution compares for the two sensors and how that's changed over time. So the light blue line on top is for LiDAR and the dark blue is for radar. As you can see, both resolution for both of these sensors has been going up. Currently, LiDAR has better resolution than radar, but as the graph shows, the resolution for radar is rapidly approaching that of LiDAR. The point here is that given the fact that the cost for radars is going down and the resolution for radars is rapidly approaching that of LiDAR, the time to work on radars is now. I'll be handing over the stage to Dash, who'll be speaking about what we as a team will be focusing on.
So to reiterate, our main goal is to make the main toolbox library for millimeter wave radar solutions. In other words, we want to try and bridge the gap between radar and LiDAR. To do this, we want to help developers from the time that radar data first comes out to the time their product is touching the hands of their consumers. We have modularized this into 3 different steps: sensing, or working with the raw data from the radar; perceiving, or using this radar data to accomplish some task; and then finally deciding where the developer can use this task to accomplish something greater. First, let's talk about sensing. Since the radar is a sensor inherently, there's going to be some noise, and we want to address this. We want to eliminate any ghost images or outliers that might come with the radar data, and we want to make the data as reliable as possible. Next, we want to compress this data, since the radar data is very large. There is a lot of information. We think this is a great time because companies have not standardized their process. So a radar from one company will read its data and save its data in a completely different way from another company. And we think this is an exciting opportunity to unify them all. Next, perceiving. As Edwin mentioned before, there's a lot of data azimuth, range, elevation, velocity, and reflectivity. This is all coming at us at over 30 frames per second. We want to be able to use this data. In contrast, think of a camera. It can be taking pictures at over 30 frames per second, but it also has a defined resolution. Every pixel in that camera frame might have at most probably about 3 different channels: a red channel, a green channel, and a blue channel. In contrast, there's a lot more in RDC. So we want to be able to use that data to accomplish these tasks like classification and detection, segmentation, or tracking. For classification, imagine taking what we have as a camera and augmenting our data so that not only can we see a frame, a single picture frame, but we also know what we're looking at, how many objects might be in that frame. For segmentation, we talked to Uber a while back and asked them what was one of their main problems. And they said LiDAR doesn't have inherently the information they need to tell the difference between a person getting out of the car and the door. Radar will help us patch up this information. Finally, tracking in the automotive sense, we want to avoid collisions whenever possible. Now, the final layer, deciding. There's obviously a lot of applications in the automotive space, but we think there's also many more outside of it. For instance, Edwin hovered over Google Soli from the Google ATOP group, and here they use millimeter wave radars to do simple tasks like changing a volume on your speaker or maybe changing the brightness and swipe gestures. And this was all done without using any physical switches or knobs. And so because of this, we think that there's a lot more applications that we haven't discovered, like security, consumer products, and then obviously automotive, the automotive field. In the coming time, we think that you as developers will be able to use this technology and accomplish really impressive tasks. So that's why we think we should work on this now. I'm going to hand it back to Arjun.
So there are many great things that come out of this 18-month-long journey that we're about to take. One of them is that we could get acquired or acqui-hired at the end of this 18-month process. Acqui-hiring is when a company is bought out primarily for the skill set of its employees as opposed to for the product or service that the company has to offer. And so these are some of the companies that could be interested. We've actually been in touch with some of these as well. Another potential exit path could be to open source our software. As Dash mentioned earlier, standardization is an issue with radar data, and if we choose to address this issue, we'd have to open source our software to unify all of these companies and their data formats. Additionally, if we hope that the software that we create gets adopted into some of the ecosystems that these companies have created, we'd have to open source our software. So that's another potential exit path. And finally, we could simply license our software and have a startup.
Very good. Thank you, guys. Before we have the other team come up, let's take a few questions about MIP. Edwin and team, why don't you guys come on up so that everyone can see you again. We can take a couple of questions about anything, about their journey, what's worked for them, how they chose radar. Anyone? Question here.
I think pretty good presentation. I'm kind of curious about why people use LiDAR then. Because if it's across the board that radar is like good fit and like it's cheaper, faster, like chart literally was like radar is better, then why use LiDAR?
So I'm going to repeat the question just so that we have it for the recording. So why LiDAR then if you're saying that radar is ultimately better?
So it's kind of a twofold reason why. One is that LiDAR has better resolution now. Radar hasn't really reached that point yet where the resolution is comparable. So that plot where you saw where the LiDAR was practically seeing everything around it, it's still getting to the point on a radar scan that you can get that same imaging level of view. The other reason is that most of these companies that are building these autonomous vehicles right now don't have a cost limit per se. Like when a LiDAR system costs maybe $80,000, that is fine for now. In fact, I think one of the most telling things we heard from Uber was that that's a cost they're willing to eat forever because their goal is not to sell a car, but to sell a ride-sharing platform. And in that sense, whatever provides the best safety and the best performance ends up being the winner. The thing is, that doesn't mean that radar is out of the picture either. I mean, in the end of the day, you're going to have complementary systems validating each other's sites, essentially. So even if LiDAR gets to the point where it's so cheap and so available and so high resolution that you can put it on every vehicle, you will still need other systems using other methods to validate what you see and make sure that you're not going to make a mistake.
Question.
So do you think that like the goal of your work is more like an interface technology where like you're taking information and you're trying to spit that out for other systems to use, or would you say that it's more like to update radar and to work on radar to the point where it can almost like replace the need for more expensive LiDAR systems or more advanced LiDAR systems?
So a common library that's been brought up a lot this semester is OpenCV because it really allows you to use a camera, like a lot of things that you wouldn't do or it would just take too long to do. So we're kind of thinking something similar to that, where you really unlock the capabilities of a radar so that you don't have to spend this time dealing with things that already have been done.
Kind of a software platform is what
Yep.
you're saying. Software capabilities platform. Okay, let's take one more question and then we'll switch over. Yeah.
How did you guys manage to, I know you guys are in communication with those companies, or some of them. How did you guys manage to put this together with your academic portion? How did it seem?
Yeah, so let me repeat the question. It's a good question. How did you manage to come up with this idea and put it together while being a student? Good question. They're looking around at each other. I don't know.
Yeah, so like as Andre said earlier, this like first semester was like kind of to explore ideas and to kind of see like what's out there to like kind of create an idea that you can run with, right? So like as of right now, I can tell you my coursework sucks, but I make it work because this is something I want to do, and I do think that what we're doing now is exciting, and I make time to actually put in some effort to be able to do some research or to do some work for our team. So I would suggest that if you do join Alchemy, you don't take like extremely hard courses. You don't do what I do. I'm taking 374 with 385. That's terrible. So, but maybe for the first semester you can get away with it. But from then on, you actually have to, I would think about it more as like maybe senior design project, but longer.
To go along with that, we meet at least three times a week, and we call it Scrum. Like we scrum together Monday, Wednesday, Friday, and in between those meetings, we try and accomplish as many tasks as possible, if we can. But we also recognize that school might be hard.
So I'm going to, at this point, thank the MIP team. Thank you guys. They're not done, right? This is just the beginning of their journey. So hopefully we'll hear from them in a year when they're about done with their startup journey. You guys may leave the stage. Now I'd like to invite our second team, working in a very different area, with a different model that I think you'll find interesting. So come on up, Converge team. I'll put your presentation up. There you go.
All right. Thank you all for coming. So we are the Converge team, and to get started, we'll just tell you a little bit about who we are. So I'm Steven.
I'm Safwan.
I'm Samuel. I'm Ryan.
All right. So a bit about Converge. So what we're trying to do is make a flexible group decision-making engine. So what that means is we're trying to make it easier for people to make difficult group decisions that involve many different parameters and variables that typically take a long time and a lot of effort for us to make. So essentially what our platform is going to be able to do is take in all of these preferences in a user-friendly manner that eases the pain of putting in each of these preferences and aggregates them all and spits out the best options and why they're the best options and who they're the best for. On top of that, what we're trying to do is learn from users' past inputs, learn from data that they provide, so that, again, alleviating the pressure on them to provide all of the inputs for such decisions. This idea came to us courtesy of Professor Yuli Vereshnikov, who is a professor of electrical and computer engineering as well as mathematics at the University of Illinois. He generously, during our ideation process within Alchemy, offered us this idea, and we all gravitated towards it and formed the team. So we'll give him a few minutes to speak about his idea.
Thank you. Yes, the idea is it's pretty simple. We want to agree in the situations we don't, and the situations happens all the time. Everybody knows that, especially, at work, after work, and between, like, even whatever. Like during the holidays, whenever several people come together, they have problems to decide what is going on, and the mechanisms we have now to solve this, to solve decision problems are not good. And but it shouldn't be this way, right? The disagreements, sometimes they're material, but sometimes they're not, and just we have to learn how to find these common decisions. And, there are theories. The social choice theory, I was preparing recently a talk, so it's 70 years old. A birthday of this theory. It was created by Kenneth Arrow in summer of '49. So the people started to study how different groups come together and form the group decision, aggregate their opinions. So there are thousands of papers written, and still we better understand the reasons of failure of the process than the mechanisms of creating something which works. So what is good about that? We know what pitfalls to avoid. We know what kind of decisions, what kind of properties those decisions should not, this decision aggregation tools should not have. And that's what we want to implement. But basically those decision-making tools, we want them, to create them not to satisfy some preconceived notion of, of what the property they should satisfy. The only thing a group decision, is acceptable when it feels fair. So you won't create a mechanism such that when you converge to something, you accept it because you feel it's your ideas were taken, your preferences were taken into considerations, and were incorporated in the whole output. So let's think about the existing decision-making tools. So the Doodle, the software, the online software tool used to find the common meeting time. It is essentially it relies on some specific mechanisms of aggregating the decision. So you vote for some particular times, giving it essentially yes, maybe 1 of 3 no votes, no, yes, maybe, and then it tells just the majority rule, right? The time slot which gets the most votes declared the winner. This mechanism, feels A, awkward, B, it is still time-consuming because if you have either too many candidates or no appropriate candidates, there is no solution. Somebody has to come in and they make a decision on top of these decisions. And above all, it doesn't feel ultimately fair, right? So if in the end some decision is not taking what you do into account, you're left with that. You cannot renegotiate, you cannot come back and say that's something else you want to do. So what we want to create, so it's the idea of this kind of my desiderata for this process, where to create a tool which will be A, minimal, so you don't have a lot of inputs, you don't have too much interactions, B, iterative. So if no decision is there, you can renegotiate it. You can return and say, okay, so let's try to see. We narrowed the field of potential outcomes. Let's go there. You should learn about yourself. So you should create some identity. It should create also the sense of community. So if you have several groups of people, each of them more or less feel fine, feel close in their preferences, then you can identify those groups and say, okay, so you have 2 or 3 big groups, so let's negotiate within essentially those 3 points. So let's try to find a compromise on this level. So so you see, there's a lot of things we can try to do. We have the theories which tells you not what to do. There are theories which tell you what kind of properties those solutions should have to satisfy the people most. So that's the tool I had envisioned, I had this sort of a dream of. And the guys decided that we want to implement it. So I think they're very brave.
Thank you so much.
Thank you, Professor Bereshnikov, for that comprehensive overview. So, so now that you guys have an idea of what the platform looks like, let's talk a little bit about what the applications might look like. So on the consumer application side, the one that excites us the most is where to meet. It could be that you want to grab lunch with a couple of friends, or you want to find a proper meeting locations with your coworkers. And that's where we think this app would be very beneficial. We take in the individual constraints from individual users and compile a list of convenient locations that would allow you to do that. We are planning to use the Google or Yelp data to find different features of different places, things like price point, things like reviews, distances from your current location, and integrate all those things in. Another thing we are looking into is the what to watch. We think that this app would be very beneficial as well, and it would enhance the entertainment experience in streaming services like Netflix. A little bit different from where to meet in that we'll probably have users input their preferences by swiping through a list of shows, and we take the metadata like genre, directors, things like that, to compile a list of shows that would appeal to a group of people. And finally, the other application would be what to listen to. This is a little bit more passive in terms of putting in user preferences, because we would just use something like a Spotify API to just compile a list of songs, or a playlist of songs that would appeal to everyone. So you would it would be completely automatic, and you would not be putting in any user preferences. Also, we have been exploring the possibility of some enterprise applications as well. As you all know, admissions is a very complicated process, and we feel like this app could definitely facilitate the admissions officers a lot. At some point when they have boiled down to a couple of candidates, I think they could use this app to make the decision by putting in the different preferences like GPAs, SAT scores, things like that. And finally, as you can imagine, like the possibilities are endless. Like there's a ton of other places where this tool, decision-making tool, could help us to converge to a better decision. I will hand it over to Sushi.
So after hearing all these applications, let's take a look at the social choice theory. So as Professor Berezhnikov mentioned earlier, the process of this group decision making can have many like messy things go around. So the social choice theory is a framework that can converge the group to determine a collective decision of the choice among the group. So so it has two main components. The first is the welfare scores. So giving a list of alternatives, each member in a group will have their individual welfare scores based on their own preference and constraints for each of the alternatives. So for example, our group will choose a place to meet tomorrow, and I prefer to meet in the afternoon, and I don't care the place or other constraints. So so then all the meetings that will be held in afternoons will have a rather high score for me. So okay, so once every individual in the group have their own welfare scores, the social choice theory will aggregate the individual scores into a collective one and gives an overall ranking of all the alternatives. Yes. So one of the aggregation functions, the first one called maximum, it will order all the alternatives based on their lowest individual welfare scores. So basically, it will make sure that the least satisfied alternatives will go to the bottom of the overall ranking list. So the group will know how each of the alternatives meet their preference and constraints within the whole group. So that's basically a brief introduction of the social choice theory, and Samuel will talk about how our engine incorporates that.
Okay, so we're going to talk about our system, the basic architecture of it. So we have developed a simple mobile app that can allow users to put in their preference, and then using the social choice theory we just mentioned before to compute the result and then send it back to all the users in order to show what the group preference looks like. So if you can see on the top right where the user interface, so on the user side, each user will be including their preference into a mobile app. And then those data will be sent to a server, where the server will be generate the welfare score for each alternative using the social choice theory we just mentioned before. And then at the end, we use the different aggregation functions such as maximum or utilitarian, try to see which aggregation can actually generate a more accurate result. And then once we aggregate those, we'll send those data back to the users so that the user will now know what's the group decision for this specific scenario. So essentially, so this is in detail the architecture. So on the UI side, you will take the preference from each user, and then also send those data to the server. At the end, the server will send the result back to the user so that each user can know what's the group decision. And the server is located at the AWS server. So essentially, the server will just be waiting for the users to input their preference and then calculate the welfare scores based on different preferences and generate numerical numbers. And then using those numbers, they will use the aggregation function to generate an overall ranking for the group. So essentially, those are the basic steps for the entire system. Yeah. And then overall, we wish to build a generalized platform for this specific app. So the social choice theory, it can work on any app, such as where to meet or what to listen to or what to watch. So all of these scenarios have share a common scenario problem which can be solved by using the social choice theory. So we wish to build a platform that can accommodate for those scenarios.
Okay, so one of the things that we're looking to integrate into our product in the near future is machine learning. So one of the things that Stephen mentioned at the beginning was that we want to spend as little time as possible for users to input their preference data into the app. So one of the things that we're going to do is develop a model that will learn users' preferences over time to sort of alleviate some of the time pressure that creates. And then along with that goes like how often users would want to explore new things, because obviously you wouldn't want to meet at the same place every time. And then that's more on the UI front end side. On the back end side with the engine that runs the social choice theory aggregation, we want to have a model that learns which aggregation functions are best for each scenario, because that sort of determines the result that you would give back to the users. Also, we want to learn a model for clustering. So we would want to cluster users based on different criteria like price or distance, and then sort of convey that information back to the users so that they can sort of see how their group sort of is similar to each other. Each of the users is similar to each other in the group. And then that can also help you come up with compromises. If, say, for instance, you have one subgroup in your larger group tending towards one alternative, or have similar preferences for one criteria, and you have another group that sort of clusters around another criteria. And finally, we want to learn a model for normalization functions. So one of the big things for our product is converting all of the user preference data into actual welfare scores. So obviously this isn't going to be the same for all criteria. So instead of just using something like a linear normalization function for all criteria, we want to learn a model that can help us decide which function we should use depending on the criteria.
So looking ahead, let's talk a bit about where we see this going. So we mentioned a little bit before that we're already looking into integrations from Yelp data or Google Maps data, something along those lines. So we definitely see a place for our product within companies that do that sort of thing. Facebook among them. Anything that involves providing content or social interactions of any kind that revolve around groups could definitely benefit from this technology. So again, what we're trying to accomplish right now is build out several consumer-facing applications, specifically where to meet to begin with, and possibly others to come. We also are looking into extending into the enterprise sector, as we discussed with admissions. We've been talking to them a bit, and we're looking to see where we fit into that process. And then long term, what we would hopefully like to develop is an API that allows our platform to be integrated by other developers into their products. We think that in the long run, if we can create a sufficiently generalizable platform, this could be applied all over the place, and we want to be able to enable that for other developers. So that's it for us for right now, but we do have one last thing. We have a working demo. So the question is, where should we eat right now on campus? So we'll show you our demo and walk you through that a little bit. Yeah.
Okay, so while they're setting up, think about a question you'd like to ask. In fact, we'll let Safwan set up, and why don't we take a few questions? Eric.
So, like this might be like an edge case question you get. Like in the cases where, like, let's say somebody has like really extreme constraints, like I can't meet during these days, but somebody else also has those constraints where I can't meet during these days. Do you guys have like a system or are planning a system for like, okay, so like you have access to a computer, so you can do a video call at this time, you know, on this day, you know, just like other ways in which like a decision can be made that probably, you know, gives a better wellness score, utility score for the rest of the group, but then like, you know.
Yeah, absolutely. One of the big things that we've been considering is how to resolve issues in which you know, it comes back and the results show that there is no good option for everyone. So yeah, several ways of approaching that we've already considered are possibly suggesting multiple options if the group is large enough and it could be split into several meetings, for instance. That's one way we could approach that. Another way is we come back to specific users if most people agree, but then there's you know, a couple of users who don't necessarily fit into the picture as well. We'll specifically come back to them with a notification that says, hey, you don't quite fit, here's what other people are looking at, does this work for you? Could you change something in your constraints that makes it work out for everyone? So that avoids the issue of having to come back and interact with every single user in those types of situations.
Another question. Yeah.
So you guys say you want to use machine learning to kind of like learn the preferences of users inherently, right? So how do you guys plan on implementing that in terms of like how will one user, or how will like your algorithm learn each user specifically, like what they want? Will they have to like submit data over time and then it learns, or like how would you guys do that?
So yes, obviously you're going to have a decent amount of user input to learn much of anything. So yes, it will, at the beginning, it will ask the user to input more of their data, but as time goes on, the model will sort of learn what they generally prefer so that they won't have to input as much data each time they come back to the app.
So how many like features do you guys have right now that you use to like
Right now, such as in our demo, we're basing decisions off of 5 criteria. So we're going to expand on that later, but as of right now, it's 5 criteria.
So, you know, there's nothing like a demo where the demo doesn't work for the first time. It's part of the alchemy process, really.
It's every time.
Sometimes it's every time. So that's what their demo looks like. So I'm going to suggest that you kind of take this route. All right? For the sake of time here. So they've gone through the trouble of actually building kind of a mock-up demo, but a real demo that connects to the cloud. And it'd be a shame to not show it, right? So I think they're going to try one more route.
There's another question.
Okay, we'll take another question. Zaid.
So, I mean, you're about to show a demo while we're on the feed, and this is actually a very classical problem that like PhD students have in their group, right? Like, for example, in our group, when we try to get food, different people have different dietary restrictions. It's very important that at least the one that has the most restriction meets, right? Otherwise, they cannot be there. So, how do you see including that? Sort of like, you know, that's basically like prioritizing people for it, right? How do you see that being incorporated?
Yeah, so part of the user input would be setting some kind of weight constraint, say that if you really do want this preference to be me, or if you don't care about this preference to be me. So if someone has some kind of restriction towards some kind of criteria, then you can just set the weight constraint to be really constrained, such that the result will try everything to satisfy that kind of constraint. So.
You know what a good feature would be? Like, you guys actually call up the restaurant just in case to double check that, you know, whatever they're saying is actually like true. Like, they can actually meet the criteria. That would be really cool. We'll be your customer.
All right, so it looks like we've got our demo up.
Okay.
So get started.
Okay, so we're going to do multiple rounds to sort of showcase what we've done. So on the first round, since we're just deciding where to eat, we're going to sort of bias it towards eating at an Italian restaurant. So right now, everyone is inputting their data. So at the top of the app, we have the distance criterion, and we have cuisine, which is like type of food. So we have Italian, Indian, Japanese, things like that. And then we have price, which would be something in the future we would get from an API like Yelp. And then ratings, also something we could get from Yelp. And then a Boolean casual versus not casual criterion.
So by the way, I'm also participating in this. They loaded it onto my phone, so.
And then all of those sliders that you see next to each of those fields are the constraint weights. So setting it all the way to the right means that as a user, you really want your preference to be met by whatever result is given. And this is the final result. So we provide the top 5 in terms of percent matching score to the group. So since we were going for an Italian restaurant, at the top there we have Nanda Milano. And then Biaggi's is down there at 4.
Well, very cool. I'm glad to see that you actually pulled the demo into a success. So thank you, Converge team. Okay, I'll give you just a few concluding remarks. Again, we are trying to grow Alchemy significantly in the fall. We're bringing commercial partners, faculty, the power of this department for a cohort of 30 students starting in September. This fits, I would highly encourage you to apply. And the application link was on the slides, which we'll make sure they're available somehow. And you can also email Stacy or email me directly, and we can provide the link to you. Okay. Thank you all for attending and being part of our first Alchemy Demo Day. Thank you. Thank you,